Well, happy Monday. Good to see you. Um, Project 3, I did bump that one out. I had a couple of people who wanted to chat, talk about it. So it was going to be due today. Hopefully you got the notice. I think Cam just emails you anytime things change. And I mentioned it when we had remote class on Wednesday. So if you got it done today, thinking it was due today, I'm sorry. But hopefully everyone's okay. We'll talk about that on Wednesday. And then we'll also talk about the final project on Wednesday, because if I give it to you now and you haven't finished project 3, you're probably not going to do anything with it. So we'll hold off on that. And then with the final project, I would encourage you to work in pairs. I think you'll get a better result out of it, but I'm not going to require anyone. It's not like an outcome for group work. I think group work, while it can be terrible in college, generally with these sort of classes, like everyone here is because they want to take this class. Yeah, I think you'll do okay. You're not going to be paired with someone who just could care less. So I think you'll do all right, and you can pick your own pairs. Like, I'm not going to assign you people. So if you want to work with someone, great. If you don't want to work with someone, don't work with someone, and that should go okay. So we'll talk about that, and then we'll get pretty close to a whole month on it. I know Thanksgiving break, some people might be traveling. Generally, I don't think we have to travel quite as much here. We're not so much of a residential school. People would have to go home for the break, so you'll probably have time Monday, Wednesday to work on it, even if you take Thanksgiving off and Black Friday off, and the day after just to recuperate from all that shopping off. It used to be a lot of fun. I used to go out and do a lot of shopping with my wife on Black Friday, and it just hasn't been as fun lately. I don't know. I don't know why. Maybe it's just online sales are easier, but there used to be some excitement about going out in person, and I kind of miss that, but that's okay. So we'll probably just do all of our kids' shopping online again, because that's just so much easier. I like when stuff shows up at my door. So Thanksgiving break, we're off that week, so no class meeting, but hopefully you got some time to work on the project. Then these last 4 topics for weeks 14 and 15 are lighter. Again, we'll come back to inheritance and recursion next semester if you continue on in the program. So we just touch on it. We say, hey, here's the topic, we'll throw a couple things at you. It's not a deep dive. So we'll have time after class. I don't expect any of these lecture portions to go the whole hour 15. So probably save a good half hour each day these weeks, or these meetings each week, if you wanted to work with your partner on the final project, or just on yourself on the final project here. I'll have some time there to work on those. I can float around and answer questions and there, whatever there. So it should go pretty well. So today we'll talk about files. We should be able to get through most of files today, if not all of it. And then on Wednesday, we'll talk about project 3. We'll go over a solution to it, and then talk about the final project, what we're going to do for that. Then we're off for the week. Lighter topics for these. Plotting and graphics are really cool. There's a lot of cool stuff we can do. We're not going to go super deep on it either. They're not topics we come back to, but there's just so many different things you can do. There's no way we can show all of it. So I'll give a couple examples and show you where, if you want to go look up more, you can go find more. But it's nice to finally have something you can see on your screen that's not text. We finally get there after a semester of stuff showing up as text on our screen. We finally get some fun, pretty things. And plotting is fantastic. The plotting library in Python is just phenomenal. You can do so much with it, which is really cool. And then next semester, we'll talk about ethics. If you do continue on, we'll talk about why you should not lie with your graphs and your plots, because you can, and people do it all the time. And we'll talk about why that's a bad idea. It's very easy to mislead people with data. You're like, but look, it's data. And then they assume you're telling the truth. But you made it be very misleading. And that's a whole fun talk next semester. So we'll get into that. And then the basic graphics is really cool. Just having something you can click on, having a text box you can type in, the ways we expect Windows to work, things we can type on and click on. It's a very different way of thinking about programming as well, which is fun. And then no final exam, right? We will get together. We can meet in person if you want to meet in person. If folks want to stay remote, I'll have a Zoom session you can join, so you can present, but you must present your project during the final exam slot. I think one person said they're out of town because they were heading back home early or something. So if you want to go early is fine, but no later than this final presentation slot here for presenting your final projects. If you worked in a pair, you could both talk. You could have one person talk. However you want to break that up is fine. Generally, with pairs, you both get the same score. And if your partner just drops off on you and doesn't do any work, stop being a pair. You don't have to be stuck with them as a pair if they just screw you over and don't do anything. Say, okay, we're no longer a pair. I'm just going to do it myself. which kind of does suck too, because then like if you expected them to do some work that's no good, but ideally we're almost done, maybe by the 7th. If you can target to be done by the 7th, you'll have a good final exam week for all your other classes and not have as much stress. That's a good target. And if you need some extra time, you got a little bit of extra time here, but we'll go from there. And then so our last lab is on the 5th here. So we'll do some plotting and graphics labs, have some time for the final project. But that's the end of the semester, believe it or not. So we are staring at Thanksgiving next week already, which feels early for November, but that's okay. And then just a little bit in December and we're done. Thoughts? Oh, I don't have chat open. Let me get chat open here so I can remember to look at it. Yeah. Is there a rubric? There should have been one. Did you email me about that? I saw an email and I didn't get a chance to look at it last night. There isn't one. I thought we had one. Okay, I'm sorry. Let's do a rubric here. So this one's 20 points. So this is for project 3. Thank you. So here's our Powerball ticket class. So the idea with our Powerball ticket here, right? It represents a single instance of a ticket. Like if you had a ticket in your hand, that's what this class should represent. So it has its 5 white numbers, the 1 red number, right? And then you can either pick the numbers on it, or you can just ask it for a random set of numbers, right? You can generate random numbers or use the ones the user gives you with that init method, right? You can have optional parameters. So if you give it the parameter, you should take those numbers. If you don't give it a parameter, you should just take the optional one, which is I'm going to generate a random list for you, a random set of values for you. Then you can go and get the winnings given the winning ticket. We don't have the little machine that you go up and scan your ticket on. We'll say, hey, here's the winning ticket. Tell me how much money you won. And it says, oh, okay, I'll compare myself to this winning ticket over here. Tell me, did you win $4, whatever that amount that you can win from Powerball, ways to win page, how much money did you win, right? Whatever, if you wanted to go up to $2 billion for the jackpot, you're welcome to go up to $2 billion. You're still going to be losing money overall with this game. So technically, the simulator might show you winning money, but it doesn't account for taxes. It doesn't account for the reduced payout because it's not actually that cash value. It's an annuity and then inflation and all sorts of other fun things here. So even at $2 billion, you're probably not winning money here, right? That sort of thing. And then this function for string, we're going to override the behavior so we can show this ticket as a string in a nice looking format here so that in our simulator portion here, we can say, hey, let's display the winning ticket, right? We can just print it, and because it knows how to show itself as a string, we can see the numbers back out, right, without too much trouble here. The simulator here is just what we would normally do with our code. The ticket here is the class part. This is the logic behind, here's the noun, here's its attributes, and here's the things we can do with it, the ways we can interact with it. The simulator is just what we would usually do in our code, right? The rest of our code here that uses these tickets. So do you want to pick tickets or buy random tickets? Sure. You're going to pick numbers. Now, we're going to ensure they're valid numbers. It would be nice for Powerball to do that. I didn't ask you to do it. We hadn't got to exceptions yet. But this would be a nice thing for exceptions to say, hey, if you give me invalid numbers, we should probably raise an exception and not let you make a ticket that's 1, 1, 1, 1, 1, 1, 1. Because like our logic here for do our numbers match? If there's a single 1 in the winning ticket and we say, hey, my ticket is 5 1s, we're probably going to think we matched 5 white numbers. Be like, hey, I just won $1 million. And you're like, no, that's wrong. So it'd be good here, but not required. We hadn't got to that topic yet, so not too big of a deal. We'll just validate it here in our simulator, and we should be okay. Excuse me. If they're random tickets, ask how many they want. So either they get 1 ticket with numbers they picked, or as many random tickets as they want. And they wanted to buy 292 million to probably get 1 jackpot. Let them have at it. Let them go nuts here, right? Then we'll generate a single winning ticket. We'll display the winning ticket, compare the tickets they bought to the winning ticket with that get winnings method here, right? So every ticket we bought, we'll hand it the winning ticket, say, hey, tell me how much you won, tell me how much you won, tell me how much you won, tell me how much you won. We'll track the total won, total spent, and the net loss. Again, if it's not generating a net loss, your program's probably wrong. That's a really good way to check that here. And then this just keeps on going. You want to keep playing, you want to keep playing, you want to keep playing, you want to keep playing over and over and over and over again. Right, so this part is our regular program logic, like the things we've done before. This is using the class to model that noun because that makes life easy for us as programmers. Nothing requires the Powerball ticket class to actually solve this problem, but it's a handy tool for us to think conceptually and for us to work out a solution to it with object-oriented programming. It's one of those tools in our toolkit here for us to do that. So for the Powerball ticket class itself, right, this is, let's do the init can accept numbers or give random values, random numbers. 5 points for that. So if your init method in the Powerball ticket class can take the user's numbers or generate random numbers, there's 5 points there. And then we'll have the Powerball ticket, get winnings, compares itself to a winning ticket argument and returns the money won, which is most likely 0 most of the time, right? 5 points for doing that. We'll do Powerball ticket class string function, right? How do we represent ourselves as a string? That'll just be an easy 5 points here, and then 5 more points for the actual simulator portion. Simulator logic, allowing user to pick or by random, tracking net loss, that sort of thing. 5 more points for the simulator. So most of the points here, ideally, are coming from this class, because that was the focus of this, is working with a class. We can write a Python class and use it to represent that noun in our solution. It looks like one person already submitted here. So if this feels unfair to you, please let me know. I'm happy to discuss that with you if you already submitted. We ran out of time is what happened, right? This has been like so long ago, I don't even remember now what happened.
I think there was a rubric, but then you put it in the wrong class.
For this one?
The whole project is like a different class.
Is that what I did? Oh, okay. Yeah. I think with my last class I put in here. Okay. So if this sounds okay, we'll use this rubric. Again, the focus is on the Powerball ticket class. It represents a single ticket. We can use it in code to be the ticket. And then what's fun here, like the simulator logic is basically the same. A little bit different, I guess, with the picking the numbers here. But if I wanted to do a different lottery, I could just use a different lottery class here. And most of the other stuff is the same. Like, do you want to pick your numbers? Do you want to get random numbers? Right? All that stuff is the same. Do you want to track your net loss? Sure, we can go and see. And then we could compare different lotteries and see which one generates the most net loss, right? Which one is easier to lose, Mega Millions or Powerball or some state lotteries, or you come up with whatever you want here. We could plug them in essentially just by changing the class here. So it helps our code be a little bit more modular, a little easier to change, be a little more flexible here. Okay. So again, we'll do the solution to this on Wednesday. We'll have time in lab today if you have questions. I'm happy to entertain questions about the project in lab as well. We'll have some time then. Wow, the whole thing moves. Okay. So let's fire up PyCharm. So we're going to get into files. Files is tons of fun. Oh, and I was looking earlier here in Zybooks. Our numbers are a little low, lower than what I'd expect. The Zylabs is a lot of work, but generally everyone says it's worth it to get that practice, right? The only way to get better at writing code is by writing code, right? We can talk about it. You can hear me talk about it. You can watch me write code, but it doesn't improve your coding. So go and write the code. Zylabs will give you lots of practice here. That's the reason I like using Zybooks. I think the Zylabs tool is really nice, and it does that auto-correcting for you. Like, if you did it right or wrong, even down to, hey, you missed a space, which is a little bit obnoxious, but some attention to detail is a good habit as well here. So
do you have to have 100 files? Just Zylab?
So it's the points are assigned a little bit weird. So like it should tell you how many points each lab is worth and tell you how many points each challenge is worth, and then participation is like 1 each.
So just do
Yeah, you want to have 100% on everything, but like if you get the labs and the challenges done, it's mostly there. And I'll be honest, if you hit like 95% or higher, I just give you the whole 100%. So like if you miss 1 or 2 things here or there, I'll give it to you at the end. But like if you only got 90%, I'm not going to round that up. But like 95 or higher, that you missed 1 or 2 things, that's okay. Like don't kill yourself trying to find every single, hey, I missed one of these little orange chevrons somewhere. But if you can get most of the way there, we're good. But ideally, again, my goal is to show you things that are not in the book And hopefully I've been following along that. So you'll see it once from me, you'll see it in the book, you'll practice it in XiLabs, you'll practice it in our weekly labs, you'll practice it in the project. So like you're getting the concepts and practice lots of different ways is sort of the goal here, lots of repetition. Because it's like learning a new language. Right? We don't really speak it out loud, but it's like a new language. It's a whole new way of learning things and communicating things. So lots of repetition is the key here, lots of practice. And you don't have to have any of it memorized. Like I go and Google stuff all the time because I can't keep it all in my head. I don't expect you folks to either. So just know where to go look up your resources, where to go find that information. Oh, well, how do I go do this thing with my lists or dictionaries? Well, just go to the chapter and look it up. Later on, you'll want to switch to Google and not go back to ZyBooks here, but Google is going to give you all sorts of rabbit holes sometimes when you start searching things because there's so much info out there. So definitely a good skill to develop. I think I showed you the funny shirt about, when I tell people I'm a software engineer, they think all the yada yada yada, I'll fix their computer, hack the Nexus or whatever. I just Google better than the average bear. That's really true. Like you're good at finding solutions online. So you'll want to get there, but for now it's a little overwhelming trying to just go find stuff out on Google. So just start with the textbook. It's pretty much all there. We don't do anything super crazy that's not in the textbook. Okay, all right so far? All right, so for files, we're finally going to get to the point where we can have data saved on the computer that doesn't only exist when our program runs. Right? That's the big difference here. Everything we've done so far only stays around as long as our program runs. And as soon as we stop the program, all that information is gone. Right? That's the idea all the way back to like chapter 1. We have RAM, our memory in the computer. That's the short term. I want to keep it around and use it while my program's running. That's nothing about the disk storage or secondary storage. Right? So now we're going to look at, well, how do I keep data around in a file that will stay, and every time I run my program, it can go read the file, or I can write a file, or I can send the file to someone else and they can do something with it. There are gazillions of processes out there in the industry that work with files. So being able to work with files is a hugely important skill. It doesn't really make a lot of sense until we get to this point, though, because there's so many things we do with them. That's why we kind of leave this for a little bit later on. So when we're working with files, we're going to read them and write them. Interacting with the file system is nice. This is interesting. Like, how do I find other files? It's a little bit more advanced. Everything we're going to do is just I don't know what that noise was. Is that from my computer?
Yeah, that was mine.
Oh, okay. All right. At one point, they were going to do like a tornado drill, but I think we missed that, or the fire drill. I'm always scared they're going to do that in one of my classes. I got in trouble one time because I told the class, like, hey, they're going to be a fire drill, just so you are aware. And apparently I'm not supposed to tell people when we're doing fire drills. I don't understand, like, why. Okay. They're like, now you messed up the test because they knew it was coming. I'm sure it's useful and it saves lives to do these fire drills, because why else would we be practicing them all the time? Because you're an adult and you don't know what to do when the fire alarm goes off. But okay. So files, there's two types of files, essentially. There are files that we'll say are human readable, or text files. All the things we've done in Python have been text files, right? This is a text file. There's text in it that we can read. Okay, it's not a machine readable, maybe machine only readable kind of file. This is a text file. We can open it up, we can edit it, we can look at it, we can see it. Python just so happens to be able to read these as well, which is nice and handy. But other kinds of files, I don't have one right now. Let me go and make a new, like a Word file here. And we'll put some text in the Word file here. Let's get some sentence. And we'll give this a close. So Word files are binary type files. The data is stored in a binary format, a bunch of zeros and ones in some particular format that some particular program knows what to do with. In this case, Microsoft Word knows what to do with this file. If I were to go and open this up, and you got this open with option, you can say, hey, open with Notepad. This is what you get. This is not human readable format here. It's gibberish, because it's not made to be read as characters. Now, some things actually do show up, because parts of this data are actually characters. Like somewhere in here, it stores stuff that's characters. The rest of it here is specific to what Microsoft Word knows goes in particular orders. So it knows, hey, let me find this line here, read this piece of information, it happens to mean this. And Word has all sorts of crazy settings, right? Your page widths, or your margins, your fonts, your spaces, like all that data gets stored somewhere in here in the file, and Word knows how to open it.
So that one little sentence has all that stuff.
Yep, just that's all the other stuff that Word needs to know about this particular document. So you can see it says the size is 11.6 KB or kilobytes. Remember we talked about bytes is 8 bits is a byte, 1,000, really 1024, but basically say 1,000 bytes is a kilobyte. So this has 11,000 bytes of information to store that sentence, because it has to store all that other information as well. Those are binary files. We're not really going to do anything with binary files. I'm pretty much going to skip over it. It's a little bit more of an advanced topic here. Later on, you can work with it in other classes. So we're going to stick to the text-based files that we know how we can read and write very easily. Okay. Comma-separated value files, CSV files. If you do any work with Excel, you can save them as CSV files. There's a way you can just read them directly with Python. You can just import a little library and say, hey, open as a CSV, and it just works. It is phenomenal. Super easy for reading data. It's really fun. But when we're working with reading files here, so let me start up a new project here. This is, new project. What week are we in? Is this week? I don't remember. 12, 13? Probably 12. Week 12 files. Now, I mentioned that the file system and being able to find particular files. By default, if we tell Python I want to read a file, it's going to look in the folder in which it's running. So the folder in which this runs here, when I just print hello world here, and I hit run, remember it says, hey, here is my Python executable, run this file here. So we could actually go and paste this in ourselves to Windows Terminal or your command prompt or bash or anything you want to do. Run Python, tell it what file to run. It's perfectly fine here. But when it goes and looks for files, it's going to look in the location in which it's running. So that happens to be our folder right here. So if I put a file inside of here, so I can say, hey, I want a new file. This is test.txt. And in here we'll have, this is line 1, this is line 2. Hi there. I'm going to add a couple lines to this text file here. If you want to go read a file here, you just say open, and you give it the name of the file. If you just give it a name, it's going to look inside the folder in which Python's running. So it works for us because we put everything in our project folder. You can be specific, and we'll talk about that in a little bit. You can say, hey, open on the C drive in a folder named Eric's stuff, open a file named Eric's secret passwords. Sure, you can be specific if you want. That doesn't work well on other people's computers, though. So this idea of a relative file is pretty nice here. So we'll say that here's my test file is open given test.txt. So it's going to look for a file. Oops, sorry. For a file named test.txt and tries to open it. Okay. Once it's open, then we can do some options. We've got a couple different options for reading. You have read lines, which gives you a list of strings where each line in the file is a string in the list. You could just read, which gives you everything as a single string. So depending on what you want to do, either way you could go about it here. So I like the read lines usually. So we can say the, contents is equal to my test file dot read. We've got read line. If you want to read a single line, so if you have a really, 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 really big file and you call read or read lines, it's going to try and load all of that into memory. For our purposes, we're perfectly fine. We're not going to have that much data in a file, but like if you have some really big data file and you try and read all of it in at once, it might be too much for Python, depending on what your computer specs and that sort of thing, and what data you're working with, right? Like don't try and load your genome into memory. It's probably a recipe for a bad thing to happen, right? So you could read a single line at a time if you want and manage one line at a time. Python's pretty good at that. Or you can read them all at once into a list of lines, or read it all just as a single string. I like read lines here. So read lines will give me that. And I can say for line in contents, we can just print the line. Nothing super interesting, but we're just going to print each line at a time here out of my test.txt file. When I run it, I get my, I can get rid of hello world here, sorry. To my friend, thank you so much for donating to their Student Scholarship Fund here at the University of Michigan Dearborn College of Engineering and Computer Science. Do you guys get the fast facts when they email those out? I don't know who they all send it to about university facts. This was neat. So in 2022, this is Hector reminded me, they had our enrollment here as a college or as a university, enrollment by college at the university, that sort of things, facts about graduates, international students, that sort of thing. 49% of new students are first generation college students, which is super cool. That's a really high number for college, which is really cool that Dearborn can do that. All sorts of fun information here, but the College of Engineering and Computer Science is now the largest college on campus here at this particular university campus. If you go back to 2020, I was looking at this for some meeting here, Castle was larger than College of Engineering and Computer Science back in 2020. So our STEM programs seem to be doing well. Maybe we're just engineering and computers. I don't know if it's all STEM or not, but it's interesting to see. But definitely in need of scholarship funds because college is just expensive. So I'm sorry, folks. I can't fix that personally. So aside from the couple $100 we raise here on Twitch. So, but you'll see we get extra new lines here at the end because when we read the contents of the file here, there's actually a new line character in the file itself. When it reads the line, this line also has that \n character in it. We just don't see it here. What we see is it goes down a line. So when you print out your line and then print itself adds a new line, we're getting doubled here. So if you want, you could change the end here and just say, hey, just don't put anything at the end. And now we'll get the contents out as normal, right? So avoid the extra new line, printing file contents. Just an option here. And again, reading a file and printing it to the screen is not the most interesting thing in the world here, but we can. So I can point it at any file and read the contents. So if I want, I can come in here. Let me go open this up. Oh my goodness, where's my open option? Open in Explorer. Here we go. And we'll go to our week 12 folder. Let me put that Word file in here. Test Word document. Test.docx here. Test again. And let's try and read that one here. So let's do test.docx. Let's give that a run. Uh-oh. Charmap codec can't decode byte something at position 6. Ugh. It doesn't even know what to do with this here because it can't read it as text. Right? So it's just not even going to give us the garbage, the gibberish here. It just totally fails on us. So just be careful with your files. Now, the things that come after the dot are file extensions. They're really just shortcuts for your operating system to know what kind of file it is. There's no rule that says you have to have these here. So I can add a file here, and we'll just call it test. It doesn't need an extension. Now, Windows is saying, hey, you don't have a file extension. It might become unusable. Yeah, I know. That's okay. Thanks, Windows. Here. I can open up my test file here and add a bunch of gibberish if I want. It doesn't matter here. In Python, I don't need to say the .txt. If I want to open the file name test, I just say open the file name test. It will give me whatever garbage I put in there. That's fine. But in Windows now, if I come here and I double click my file, it says, what do you want to do? Because your operating system says, oh, here's your file extension. You must want to use this program to open it. Like when the docx file, oh, you must want to use Microsoft Word to open this file. Oh, a text file, you must want to use Notepad to open this file. Oh, it's a .py file, you probably want to use PyCharm to open this file. The file extensions are just helpers for your operating system. They're not required at all, but it makes operating systems work nicer because people just like to click things, right? And not have to say, oh, well, I want to use Firefox to open this file. Like, it has no idea what I want. So Windows Media Player, it's just is just guessing at this point. Like it has no idea because we didn't tell it what type of file it is. So the extensions are useful for your operating system to know what kind of file it is. Okay, but you don't need them. Totally optional. I like having txt on all of our text files because then I can just double click and open them up here in Windows. So generally I'll try and always add the txt to files when we write our own files here. But we can read anything we want, assuming it's text and it doesn't crash on us. Okay, so we can open some files. Yeah, and going over printing the end, sure. So when you write a file, you still use open, but you now say, hey, I want to write the file. So you give it a W, which is fun. So let's ask the user. We'll get a file name. Is an input of the name of a file to write. And I'll say, here's my file to write. Wrote is an open of the file name and a W. So whatever file name you give me, I'm going to go open using my open function here. And I'm going to say, I want to open this for writing. Use W for writing. So there's actually a default here. When you call open, the default is R for read. But if you don't give it a read or write, it assumes you want to read. So it's the same open function. Here we're going to go write. Now I'm going to take file to write, and I have some options. Mostly it's write here. So I can say file to write dot write. What do I want to write to the file to write here? I don't know, let's say here's line 1 from Python. And then let's try it again. See if we can get line 2. Okay, so enter the name of the file to write. What name should we call this file? It can be anything. Yellow. Okay, now we have a yellow file. It has, here's line 1 from Python. Oh, it's all on a single line. When you're writing to a file, you need to give it new lines. You have to do your own new lines, which is a little bit annoying here, but that's okay. Writing our own new lines. Okay, so let's try it again. So let's give it yellow. Now we get, here's line 1 from Python, here's line 2 from Python. But notice the other stuff got blown away. When I said write yellow, it overwrote the file. So we got to be careful here. Warning, this will overwrite file. So if I were to run this again and say, hey, let's give it test.txt, I now lost what was in my text.txt because we overwrote it. Right? I could just give it test. Now I lost what was in test. And we overwrote it. We can give it test.docx. Python doesn't care what the file extension is here. Word unreachable content. Yes, we used it. Can't read it. Has no idea what to do with it. So when we tried to open it, it said Word can't open this file here, but we can open with Notepad, and now it opens up just fine because it's actually a text file. It's no longer a Word file. Windows thinks it's a Word file because the extension is docx. It's a doc file. Must be a Word file. But nope, we did a bad thing. We overwrote it here with Python. Sure, we broke it. That's fine. It's up to us. So just a warning here. You can essentially lose the contents of files if you're not careful. So if you want, you can open a file for appending. If you give it A, we'll open the file and add to it at the end here. So if you want to make like some sort of log, and every time you run your program, you want to add to a file here, sure, we can open it in append mode and it overwrites it. Worth noting too, if the file's missing, it gets created with write mode. If the file's missing with read mode, it doesn't work. So if you want to say test2.txt and try and read the file, we get file not found error. We get an exception. There is no file test2.txt. Couldn't find it. So with read, it could just crash. With write, it's like, okay, sure, I'll make a new file. No biggie. This crash if the file doesn't exist. read mode, write mode, append mode. You can read and write at the same time. This gets really awkward and a little bit tricky here because you have to remember where you're reading from and where you're writing to at the same time, and a little bit more of an advanced topic typically. We don't usually get into that in your first semester, but it is possible to open the file for reading and writing. Generally, I'll say open it for reading, and when you're done, open it for writing and overwrite it. Is a little bit more simplistic approach, a little slower approach, but it works out pretty well, just simply thinking about it that way. Other interesting things, when you're writing files, there's actually a little bit of a delay between Python and the operating system and the file. So it does this thing called using a buffer when you output. So it doesn't immediately write stuff to the file. There's some sort of buffering that happens because in terms of how fast stuff runs, running stuff in Python really, really, really quick. Showing something on the screen is a little bit slow, right? When we did a loop, we said, hey, let's count to 1,000,000, or we did the loop where display all the times, the 24-hour clock. That took a little while to write because writing something to the screen was kind of slow. Writing something to a file is also comparatively very slow because memory is really, really, really quick. Your disk is much slower. Even with the solid state drives, which are faster than the old spinning magnetic head disks, it's still slower than RAM, than your memory. So you don't want to, every time you call the write method, actually go out and call that operation because it's going to batch them essentially and buffer them to say, hey, let's wait till we have enough data to write, and then we'll ask the operating system one time to write. Because it doesn't know if we're going to write 1,000 different times or 2 different times. Python has no idea. So it does this buffering process to try and optimize its writing. So usually that's good for us here. Every so often it can get a little funny. So if you want, you can flush the file out to force it to write to disk. We almost never need to do any of that. And our stuff is not really time sensitive. Like, we're going to work on the data. We're just going to work with the file. If you have multiple programs working on a file all at once, things can get really messy. And at that point, don't use a file, use a database. Right? Use a tool that's made for that sort of multi-user access. But you can do interesting things with your buffering. There's an OS module you can import if you want to work with the operating system and work with your file system to do all sorts of fun things here. In Macland, we use backslashes. Oh, I'm sorry, Macland, we use forward slashes. Linux and Mac are forward slashes. In Windows land, it's backslashes for paths. So if you want to open a very particular file, so on let's go find my C drive here and make a temp folder. And inside of the temp folder, I'll add a test.txt file. So I can open c:\temp\test.txt, right? Because the backslash character is that escape character. If you give it 2 of them, you actually get the real backslash. You're escaping the escape character. This was way back like chapter 2, I think. It's okay if you don't remember. So I can open specifically the test.txt file from this path here. So this is a absolute path. Absolute path. That's the drive and all folders. A relative path just has the file name. It's like relative is relative to where Python's running. Absolute is it's always here, this location. Oh, we didn't add any contents to it, did we? Test file on C temp. Let's try that one more time. There. So now we get the test file on C temp. And we got the contents out. So you can open a file, but now if I send this to someone else, they probably don't have this file. Where like if we're only using relative files, I can read and write files in that same folder wherever they're running it. Life will probably be good. So absolute files are a little bit trickier to use, a little riskier to use sometimes. Relatives are usually pretty nice and handy. You're like, hey, if you want to process a file, just drop it in the same folder here as your Python program, and it works out pretty well. Now, I think that it's actually smart enough to do the forward slash. So let's try it. I don't remember. Yeah, so Python's gotten a little bit better, a little bit nicer, a little bit smarter about it. If I give it forward slashes, it knows what to do here. It used to be you'd have to be very specific, and like the forward slashes would confuse it. that's not so much anymore. This was older versions here. We realized that was really obnoxious for people. But here's a fun thing. You can make a set of log files if you want based on year, month, and day here. So you can use a date time, get the year, get the month, get the day, and then create your file path. This is OS path join. So it takes a bunch of things, joins them together with the correct separator, forward slashes or backslashes here. Tries to read the file, reads the file, sets the current day. Like it will go and read a bunch of logs here. Sure, it's a fun thing to do, depending on what you want to do with your program. So a lot of like automated processes that say, hey, we'll just run this script every day to do something with files that get dropped somewhere because someone sends me files, a vendor sends me files, or a customer sends me files, and I have to go do something with them. It's nice to log some sort of information, and like keeping your logs organized is really nice because then you can see what happened and open up and see what was going on here. So joining the path is great. You can split a path just like you can join and split strings. You can split and join paths. Not the most interesting thing. The path exists or path is file is super handy. So you can say, hey, is there actually a file here before I go and read it here? So when I say, hey, enter the name of a file to write here, let's go see if that file exists. Right, so I can say, hey, if we got an import OS here. Import os.path.exists, given the file name, then we'll warn them. Right? We can print there is already a file name. Do you want to overwrite it or something? Overwrite it, and then if they say yes, do something with it. Yada yada yada. Otherwise, we just don't. Right? Sure, we get to get some input, and sure, we'll get choice. Some input. I guess that could be this prompt here then, right? Don't need to print it. I'm going to overwrite it. And then if choice is equal to maybe lower equals yes, then we'll go do this thing. Sure, so we can ask them. So, okay, test.txt. There's already a file with that name. Do you want to overwrite it? Anything other than a Y doesn't happen. I mean, we already have the same contents, but you can check to see, hey, if the file exists, let's go warn them about it here. So this is really handy to see, make sure we don't do a bad thing, because users will do all sorts of funny things, right? And then complain that they lost their file. You're like, well, that's what the program does. It overwrites files. Like, well, your program should warn me. It probably should. That's pretty fair. Like, if you're going to be destructive, you probably want to confirm with the user. Make sure they know what they're doing. Oh, that wasn't it. Back to here. OS walk is really neat. We'll play with this in lab, because walk is really fun. It will take a folder, and it will give you the directory, all the subdirectories, and all the files in that folder. Right? Directory is just a name for a folder. Right? So if I want to go to my Python folder, do I have that over here? Documents, I will just open it up over here. Open this. Open in Explorer. So if I look at my GitHub 1500 folder, if I were to walk this directory here, right, it's going to give me this one. It's going to give me all of these subdirectories, all the folders inside of it here, and all the files inside of that. So you can go through and you can print out all the information about all of those values here, and we can loop through for each one of those and kind of go through and see what's inside of all of them. Right? You can see the names of the files and those sorts of things here, which is really fun. It's just kind of cool. So it's a way to see what's there, kind of explore with walk. We'll play more with that in lab. We can walk through a folder and try and find it. Doing this logging by name is actually really interesting here. And we'll try and simulate that so we can make our program log. Like if we were actually Powerball, we could say, hey, we did the drawing on this day, here's the winning numbers. And we can make a Python program to do that if we wanted to. That sort of thing. That was walk. So binary data, and we're just real briefly touching on that. It's data written out by bytes at a time. So it's not text-based data. It's not the ASCII data or the Unicode data. It's actual bytes, the zeros and ones of particular formats. So their example is really cool. Is you can take a bitmap file. Bitmap files have very particular formats for images, and you can open it up and you can see what the contents of it are if you understand what they do. And then you can even go and change it here. If you know how bitmaps work, you can go and change something inside of the file, change the bytes here, and you get a different image. Like software that deals with image manipulation can open up and change individual bytes and all sorts of fun things here like that. That's way more advanced than we're going to get into, but you can do that sort of level of detail with binary files if you understand the binary files. Yeah, packing and unpacking is just crazy. That's all fine. The other fun thing, when you run Python, you can give it arguments, right? We already give it the name of our Python file, right? When we call Python exe, we say, hey, here's the Python script I want you to go and interpret. Go run this file. You can give it additional pieces of information here that are not based on like user input. So the idea is, hey, if I want to pass it the name of a file to process, hey, here's a file I got from my vendor. Here's all the chart. Here's like all the invoices from my vendor. I can make a Python program, go and give it this name of the file, and it can go and do whatever it wants to do with that file and figure out, total up my bills or whatever we're going to do with our little accounting software sort of thing. It can go and operate on a file as an argument. So if we were to automate that process, we can say, hey, run Python and run it on a file that exists in here. And you can run Python for every file in a directory or that sort of fun thing if you want. So you can pass that as a argument. That's the sysargv. We don't usually deal with these at all, but in the sys module, it's an argument that you give it, which is kind of fun. And then the last one here, so when we're working with files, the right thing to do is to close your file when you're done with it. I was being bad and not closing it here. So when we're done with our file, we want to close it. So we'll take our test file, .close. So when you're working with files, you open it, you read write it, and then you close it. When Python ends, when the program ends running, stops running, it automatically gets closed. So I was being lazy and not being explicit about it. But if your program is like long running and working with multiple files, you want to make sure you're closing your files when you're done here. After you are the file, close it explicitly. Explicitly? So the other shortcut is we can use this with notation. The with will automatically close it for us when we're done. So we could say the syntax is a little bit backwards. We say open and then as something. So it'll call open, call it like it's like my file equals open my text file, and then when we're done, we will close it. So it's just a good practice to use this with notation here. So we could do the same thing here for our, let's see, that's the test file here. Let's do that. So it'd be like with open, wow, that was test.txt as test file. And then we'll go and get the contents out, and we don't need to close when we're done. Oh, is it upset because you already have test file? Open. No, I said while with. That's why it's upset. Or to above. Oh my goodness. With will call close at the end. End of the block. So it's just a good habit to get into similar to use with, because that way you don't have to remember to do close. It's not going to hurt anything for our short programs, but again, if we're doing something that's long running or opening multiple files, you don't want to have multiple files open at once. It'll upset Python here. So just make sure you close them when you're done. All right, we are cruising. CSV files, these ones are awesome. So to open up a CSV file, there's a CSV module you can import here. So if we were to write some Excel file real quick here, let's make a new workbook here and save it as a CSV. So let's get some data out here. How about, what would be fun? Let's do, what do you want to have? Like day and temperature? Would that be fun? So like November, let's do the 1st, November 2nd. Okay, sure. We'll take your format, Excel, up through the 14th here, and then we'll do the temperature. So I don't actually remember what the temperatures were here, so we can make up some numbers, but it was like pretty decent week before last. Last week was not so good, right? But the week before last was like 60s and 70s, wasn't it? Ish. Okay, we'll just throw in some numbers here. And then it got cold somewhat time after that. 75, 80, why not? And then like 65 and 52. And like last night it was like, or yesterday it was like 40, 35. Sure, why not?
There's 40.
40, okay. Is that the day of the game?
Yeah, that's the only reason why.
Sure, so we'll just throw in some numbers here. So we can save this as a CSV file. I want a CSV format here. I'll just put that on my desktop for right now. So here's some temp data. So if we go and open up temp data, Excel knows how to open CSVs, or if we open it as a text file, not WordPad, no, I wanted Notepad. Open with Notepad. As a text file is just, here's a value, comma, here's a value. Here's a value, comma, here's a value. Here's a value, comma, here's a value. So that's a comma separated value file here. So let me move this into our folder here for our CSVs. And we'll try and open that one up. So we'll import our CSV module. And then with the CSV, you say CSV reader given the file that you've opened. So it's a little bit funny. So we still use the with notation, and then you have a second step here that says, hey, please go open it now as the CSV reader here. And then we can go through and print out some data here. So let's steal that for a second. This will be my temp data.csv. The read is default here. That's okay. We can be explicit if we want. This is my temp reader. Read the CSV file. And we can get the row and then the row data. Sure, why not? Let's go run that. Test.txt. Yes. All right, and here's our CSV data. Oh, got a weird first character there. I wonder if that's because we opened it in some weird format. That was a little ugly. But we can see we get the data out really nicely, and each individual row, right, is already turned into a list of values there. So we can iterate over each value in each row and do something with it. Like in their example, we had all the grades inside of it here. You know, you can put all your grades for different scores. Sure. And whatever your format for your data happens to be, we can quickly read CSV formats. You don't have to like go and split the string and that sort of thing. And what gets weird is when you're dealing with CSVs and you have stuff that has commas in it. It's like if we were to say November 1st, 2022, like, and have a comma inside of it here, and November 2nd, 2022, and on and on and on to save as a CSV. It gets really messy really quick. You open that with Notepad. But what happens is it will quote the data that has a comma inside of it. So that when you go and read a CSV file, if you see a quote, you read to the end of the quote. You don't split just on commas. So like if we tried to write this ourselves, our first instinct would be, okay, we'll just take each line and split on commas. We know how to string split. But if you string split on commas and ignore the quotes, you've done a bad thing, right? Versus our CSV reader just knows how to do it. Yes, overwrite it. Right, it just, oh my goodness. Okay, our first one got screwed up because of that character. I don't know what I did wrong with that file. The second one's perfectly fine. I think I did something wrong with the file. We'll just blame Excel. It's probably Excel's fault. But it would normally give us the correct value here, and we have the comma inside of it because it recognizes that as a single field. So that's the advantage to the CSV reader. What did I do wrong with this character? I'm super confused now why it's there. Can I just open this in a Notepad? Here, let's see if I can change it here. Back that out. Put that back in. One more time. Nope, still there, even with Notepad. Wow. All right, I'm confused. It's okay. Probably not worth spending too much time on. We could probably Google this. That's what we'll do. I'll Google this later, and we'll find an answer and figure it out. But really nice, easy way of reading particular kinds of data here, which is nice. You can also write with CSVs. So if you have a whole row worth of data, you can write the row all at once, and it converts it to comma separated value format. This one's not so bad. You can string join on commas pretty easily here, but it's nice that it just does it for you. So if we're working with lots of data, CSVs, it just works nicely here, which is really fun. Okay, thoughts, questions, concerns? This is all new, which is fun. We'll be using files in our final project. So we don't have an individual project to work on. We'll be incorporating files so that we have data that will live long-term between runs of our program. So our final project can build on data that we already have and have information out there that we don't have to re-enter every single time. That's also sort of a pain. Like when we were doing some of those gradebook exercises, okay, now I have to enter a name, now I have to enter an assignment, now I have to enter a score. It'd be nice if I could just save all that data and have it show back up, that sort of thing. Okay? You folks look tired. It is a Monday. We have to get some coffee. Another reminder, winter registration is open. I think it opened a little while ago, but make sure you do register for winter. That's coming up before you know it here. And other than that, I think we're in good shape. I will see you folks in lab then. Okay? Awesome. Thanks, everybody.